For our third question, we're asked how much more power is generated if a crate is pushed 6 meters in 3 seconds rather than in 12 seconds. We're going to look at the math of calculating the power, and then we'll look at a kind of shortcut way of doing this. We're going to start with our power formula. Power equals work over time, and work equals force times distance times the cosine of theta. We don't have to worry about the theta here because the work is done in the same, the force is done in the same direction as the displacement. So we can just kind of ignore that cosine theta there. We know that the work is the force, which is 7 newtons, times the displacement, which is 6 meters. So the work is 42 joules. Now let's calculate that power. The power, if we push it in 12 seconds, power equals the work, which is 42 divided by 12. So the power is, do the quick calculation, 42 divided by 12 gives us 3.5 watts. Alternately, if we do power equals work over time, and this time, instead of 12 seconds, we do it in 3 seconds, power equals 42 joules divided by 3 seconds, for a total of 14 watts. You can see that more power is generated when the crate is pushed in a shorter period of time, because power is the rate at which work is done. And so to answer the question, we want to know how much more power. So all we need to do is take our new power, 14, minus our old power, which is 3.5, for a total of 10.5 watts. So 10.5 more watts are generated if we push it in 3 seconds. The shortcut I was talking about was we can see that we are now using 1/4 of the time. 1/4 of the time, which should mean that we are going to generate 4 times the amount of power. So if we multiply 3.5 times 4, we get 14. That is our new power. If you have any questions, please let me know.